Welcome to the students of class 12. Students, today we are again going to discuss the numerical problems of the chapter 3 of your NCERT, that is current electricity. Previous video I have made, in that I have elaborated the numerical problems related to the topic electric current. Now further proceeding, students, I am going to take today another method of finding electric current, and mobility we will discuss current density, we will discuss resistivity, we will discuss conductivity, we will discuss resistance, we will discuss conductance, and these all things we will discuss in this lecture, and related numerical problems also. Students, before starting the lecture, please like, share and subscribe our channel. Now let us start. Students, I have left last lecture at this formula I is equal to NEAVD, where N is the number density of charged particle, E is the charge which electron have, and A is the cross-sectional area of the wire, and Vd is the drift velocity. Let us visualize it. Suppose this is the cross-section and this is another cross-section. Now this is the section of wire having length L, having cross-sectional area A. In that, if it is connected to a battery, this is positive terminal of the battery and this one is the negative terminal of the battery. If we have connected this, then students, current will move from positive to negative terminal, but the electron will move from negative to positive terminal. Students, suppose the potential difference between the plates of the battery is V. So, if assuming that the resistance of these connecting wires is 0, so the potential difference between these two terminals will also be V. If students, there is a potential difference, here must be electric field. The direction of electric field from positive to negative direction. Here, towards this direction will be electric field. Now students, free electron will feel a force and drift towards the positive charge. So by this way, whatever velocity they will acquire, the velocity is said to be drift velocity. These things you have been taught, I am only elaborating these things. So students, suppose it has drift velocity Vd and it has the charge E and N. N is the number of electrons per unit volume. Students, keep one thing in your mind. According to the law of conservation of charge, whatever amount of charge will insert in this section of a wire, that much amount of charge will leave the section of wire. Students, one question is for you. Suppose electric current is passing through a wire, then will it be neutral or charged? Students, that will be neutral. According to the conservation of charge, whatever amount of charge will insert into the conductor, that much amount of charge will leave the conductor at the same time. So neither it has the loss of electron nor it has excess of electron. So why it would have charged? Why it would have charge? So we will say it has been charged. So students, see here, I is equal to NEAVD. This is the core formula, student. With the help of this formula we can find other formulas also. So let us try to appreciate and try to understand. I is equal to, if I send A here just below the I, then what would we have? This A came here, so what it has become? It has become J. This is what? This is current density, NEVD. This is another formula. Now students, we know that here only I will write. We know that Vd drift velocity is equal to small e capital E tau upon m. This thing we know. Students, beforehand I want to explain that Vd upon E is what? Is E tau by m. This quantity, do you know what is this quantity? This quantity is nothing but a mobility. This quantity is nothing but a mobility. For finding mobility you can use this formula or this formula. Another formula you can also derive from this formula. We know that, students, if the length of cross section of a wire was L, then and potential difference between the terminals of the wire was V, so we know that E into L is equal to V. This formula you have been taught in the previous class. So students, what will be the value of E from here? V upon L. So put this value in this equation, you will get new formula. Mu E Vd V by L, you will get Vd L upon V. This formula you will get, students, or whether I am going to erase it, just you do it by your own. Okay, this is what? This is drift velocity. This formula, from this formula, with the help of this formula we got this formula, and with the help of this formula we got this formula, this formula and this formula. Once you take a look, and thereafter I will erase it, please. Okay. Now students, we had this formula. So with the help of this formula we have got current density. Now other things also we are going to find with the help of this formula. Now put the value of Vd. Vd, I already told you that Vd is equal to small e capital E upon m tau. So put the value of Vd over here, you will get Ve tau by m. So students, this is nothing but Ne square A E tau by m. Now students, if you want to send A just below the I, so this value, you know, I already told you, E tau by m. So this is nothing but this is J, this is current density. And students, see here, N E square tau by m into E. What is this, student? This is the reciprocal of resistivity. Means this is nothing but 1 upon rho E. So what the value of 1 upon rho? 1 upon rho is sigma E, where sigma is what? Conductivity. So another formula we have got, students. What is this? This is equal to J. This is J is equal to sigma E. Now the current density will be along the same direction of electric field. This formula also you can apply for finding J. Once you note it down. Now students, other formulas we are going to derive with the help of only this formula. Whatever you want to find, whatever you want to find out with the help of this formula, you can find. I already told you, students, this formula is the core formula of this chapter. So each and every formula you can find from this formula only. May I erase it? Okay. Now students, again came to this point. Another thing we are going to find out. I is equal to n square E tau by m. So students, now put the value of E. Students, you have already been told that the section of wire of length L. What was the length of cross section of wire? Section of wire was L, and cross section area A. Cross section area A, length of wire is L. Okay. So V is the potential difference between these two terminals. So electric field will be what? E is equal to V by L. So student, put the value of E over here. You will get n square A tau A and V tau by ml. Students, according to the Ohm's law, we know that V upon I is equal to R. So shift the value of I just below the V. We will get ml upon n square A tau V by I is equal to R. Student, this is the resistance of the wire. What do I mean to say resistance of the wire? Resistance of this cross section. Resistance of this cross section. Whose length is L, whose cross section area is A, number density is N, and the mass of electron is M. Now students, let us take this formula, and with the help of this formula we will elaborate the Ohm's law. Once you see, I am going to erase it. See? Okay students. Once students, let me check that camera is working or not. Yes, working. See here students, R is equal to ml n square A tau. This is the resistance of that cross section area what I have made before few seconds. Now students, let us discuss the resistance with the help of this formula. Students, the mass of electron we cannot change, number density of electrons we cannot change, charge on electron we cannot change, relaxation time we can change, length of wire we can change, and cross sectional area we can change. So here you see students, R is, this is, so this is the quick revision and nothing else. ML E square A tau. Students, you have been taught in class 10 that R is equal to, this was very popular formula in class 10, R is equal to rho L upon A. So compare this formula to this formula. You will conclude that rho is equal to nothing but M by N E square what tau. This is resistivity. Now students, the reciprocal of resistivity is called what? Conductivity. Sigma is 1 upon rho. And hence this implies that sigma is equal to N E square tau upon M. Now students, let us discuss few more important topics about the resistivity. Conductivity you people have been understand, I think so. Only simple thing is this, only you will have to write the reciprocal of resistivity is called conductivity, and it is denoted by sigma. Okay students, and one more thing, reciprocal of resistance is what? Reciprocal of resistance is nothing but conductance, 1 upon R. Reciprocal of resistivity is conductivity. Reciprocal of resistance is conductance. See here students, the unit of R is what? Ohm. So its unit is nothing but ohm inverse or this symbol, this is ohm inverse, this is what? This is mho, mho. This is what? This is nothing but ohm, ohm, and its inverse, its inverse mho. So the unit of conductance is mho, mho. Now students, let us discuss few more important things about resistivity, M and E square tau. So here you see students, rho is the resistivity. You cannot change this thing. Mass of electron you cannot change. Number density you cannot change. Or if you can change, suppose if you can change, now you will increase the n, rho will decrease. On increasing n, rho will decrease. On decreasing n, rho will increase. This thing you cannot change. Means what is the value of this? 1.6 into 10 power minus 19 coulomb. So this thing you cannot change. Only this you can change, this or this. This you can change. So from this we conclude that rho is inversely proportional to tau. This is the same case as we have seen before in the case of resistance. If you will increase the temperature, the vibration of molecules will increase, so relaxation time will decrease. When the relaxation time will decrease, obviously if this will decrease, then this will increase. On increasing the temperature, resistivity will also increase, resistance will also increase. Students, but a very vital and important thing I am going to tell you. But this will be only in case of conductors. Only in case of conductors. In case of semiconductors, rho is inversely proportional to T. When you will increase the temperature, resistivity will decrease in case of semiconductors, not in case of conductors. So in this chapter we have confined ourselves to study the conductor, not semiconductors. That we will study in the last chapter of the second book. Okay students, now from these two things you have concluded that R is directly proportional to T and rho is also directly proportional to T. So obviously one article is there in your NCERT book, temperature dependence of resistance, temperature dependence of resistivity. These two topics are there in your NCERT. Go through that. Only a few things I am going to tell students. As I already told you that when you will increase the temperature, resistance will what? Increase. So let at 0 degree centigrade resistance is R naught, and at T degree centigrade resistance is RT. So students, increase in temperature means RT minus R naught is directly proportional to initial value of resistance. These are the experimentally found truths. Okay, now increase in resistance is directly proportional to change in temperature, means delta T. So from 1 and 2 we have got RT minus R naught is directly proportional to R naught delta T. Now students, for removing the sign of proportionality, we will have to introduce a constant of proportionality. That will be alpha in this case. Alpha delta T. So we have got RT is equal to R naught plus alpha delta T. This alpha is coefficient of resistance, coefficient of temperature, coefficient of resistance. Now here you increase temperature coefficient of resistance. In the same way students, you will get one more vital formula in the form of resistivity. Resistivity at temperature T equal to R naught. Students, one misprint is there because this was R naught here, so here will also be R naught, and here will also R naught. This will be the desired formula. This is the temperature coefficient of resistance. Now students, let me simplify it once more. So RT, R naught is common, 1 plus alpha T, alpha delta T. This formula you have seen in your book. In the same way, for resistivity also you will get the same formula. Rho T is equal to rho naught 1 plus alpha delta T. Here alpha is the temperature coefficient of resistivity. Here in this case the temperature coefficient of resistance. Students, what is the alpha? Temperature coefficient of resistance. Here temperature coefficient of resistivity. How it has defined that you have been taught, but with the help of this formula you can find the value of alpha. Alpha will be nothing but RT minus R naught upon R naught into delta T is alpha. In the same way, in the form of resistivity, you can find alpha. Students, more or less all formulas I have covered today, and the numerical problems we will discuss in these on the basis of these formulas in the next video. Thank you students for watching the video. Thank you.